Welcome to Thuma Mina Teaching. This is your sixth and final lesson for Grade 9 Natural Sciences Term 2. In this lesson, we will continue our discussion regarding the reaction between acids and bases. Our first reaction will be between an acid and a metal hydroxide. The second reaction would be between an acid and a metal carbonate. And our final reaction between an acid and a metal. Remember that all of these reactions form part of our neutralization reactions. We have two key terms for the day. Term 1 is a solvent. A solvent is the general name given to a liquid, such as water, in which a solid dissolves. Term 2 is a solute. A solute is the name for a solid that dissolves in a solvent. In lesson 2, we learned that when a metal reacts with water, a hydroxide forms. Sodium hydroxide, more commonly known as caustic soda, is a hydroxide and is often used in the production of soap. The word soap is supposed to ring alarm bells in your head. Can you identify whether it is a base or an acid? Bases are known to be soapy and therefore all hydroxides are bases. Now, can you guess which reactants will deliver the product sodium hydroxide? If your answer was sodium and water, you are 100% correct. Because sodium hydroxide is a base, it has a pH value above 7. If a metal hydroxide were to react with diluted acid, the products that form will be a salt and water. The type of salt that forms will be greatly dependent on the reactants that were used. The general equation for this type of reaction is as follows. Acid plus a metal hydroxide. The arrow indicates that a chemical reaction is taking place between the two reactants. And the products that form are a salt and water. In lesson 5, we learned that a salt in chemistry is known as any compound that forms when an acid reacts with another substance whereby the hydrogen atoms are displaced by a metal atom. Let us study an example of such a reaction. Again, I would like to remind you that this is also a neutralization reaction because hydroxides are bases, and if I'm to add an acid, neutralization would occur. For our reactants, we will use diluted hydrochloric acid and sodium hydroxide. The word equation will be as follows. Hydrochloric acid plus sodium hydroxide. The arrow, sodium chloride plus water. Do you think you are able to write the chemical equation for this reaction? If you struggle, please refer to lesson 2 to sharpen up your knowledge. The chemical formula for hydrochloric acid is HCl. The formula for sodium hydroxide is Na and then two capital letters O and H. The salt that forms is sodium chloride, Na for sodium and Cl for chloride. And we all remember water's formula from grade 8 as H2O. This equation is balanced. Interestingly, the salt that forms we use every single day in our kitchens. Can you guess what it is? It is the table salt we use in our food. Let's head over to High School Stellenbosch where Ms. Lamprecht will show us the experiment for this reaction.
When an acid and base reacts with each other, it forms a salt and water. I decided to use diluted hydrochloric acid. Hydrochloric acid is safer to use diluted than when concentrated because it can cause serious burns to your skin when it comes in contact. The hydrochloric acid will be added to the burette. A burette is used when doing a neutralization reaction because this reaction requires extreme precision and the end point can be reached by a single drop. Once the hydrochloric acid has been added to the burette, I take the sodium hydroxide and add it to the volumetric flask. The sodium hydroxide is a base. To be sure that we know when we reach the end point, I will add universal indicator to the sodium hydroxide to indicate that it's still a base. The dark purple color indicates a strong base. You will then add the hydrochloric acid to the sodium hydroxide by using the burette and opening the tap to let acid enter the base dropwise. The hydrochloric acid and the sodium hydroxide are now performing a neutralization reaction. It is very important to stir your solution to ensure that the hydrochloric acid spreads equally through the base. Our color change to green has taken place. The solution has now been neutralized.
In Ms. Lamprecht's experiment, we found that the salt, the sodium chloride, had dissolved in the other product, water. The sodium chloride, or table salt, was the solute, and the water served as the solvent. If I wanted to separate the table salt from the water, I would have to empty the contents of the beaker into an evaporating dish. Afterwards, I will heat the mixture until all the water has evaporated. What will remain is a white substance that is exactly like the table salt we use in our kitchen. Let's have a go at the following questions. What is the general name given to a liquid in which a solid dissolves? It is called a solvent. Can you then tell me what is a solute? It is the general name given to a solid that dissolves in a liquid. Now this concept can be explained by making coffee. Once we place the coffee into the beaker and we add the water, the coffee now dissolves in the hot water, making the coffee the solute and the hot water the solvent. Which general product forms when metal reacts with water? The product that forms is called a metal hydroxide, and as we know, hydroxides are considered to be bases. What is the common name given to sodium hydroxide? The answer is caustic soda, and we use caustic soda in the production of soap. Which reactants would deliver the product potassium hydroxide, and are you able to write a chemical equation for the reaction that takes place? two reactants involved are called potassium and water. The chemical equation would be 2K plus H2O, with the arrow indicating that chemical reaction, and our final product being potassium hydroxide. Now, when potassium hydroxide would react with a diluted hydrochloric acid, which products do you think would form then? The products that form are called potassium chloride and water. Potassium chloride, which is the salt in this case, formed after the hydrogen atoms in hydrochloric acid was displaced by the metal atoms. Now let's challenge ourselves by writing the chemical equation for this reaction. Potassium hydroxide, the symbols we use for this is KOH, hydrochloric acid, HCl, react together. The metal atom potassium displaces those hydrogen atoms in hydrochloric acid, and now a salt forms called potassium chloride, KCl. What remains is two H's and one single oxygen, thus giving me a formula for water. When we have a cut in our mouth, we gargle or rinse with salt water, which cleans the wound. Now, how would we go about separating the mixture of the two compounds? Table salt or sodium chloride and water. Because this is a mixture, we would separate these two compounds based on their physical characteristics and not their chemical properties. Water has a boiling point of 100 degrees. If I were to decant this into an evaporating dish and heat it up to 100 degrees, the water would evaporate, undergoing a phase change from a liquid to a gas. And the only thing that will remain on my evaporating dish is the white substance that we know would be table salt or sodium chloride. Our next reaction is between an acid and a metal carbonate. Limestone and cement are made up of carbonate molecules. In our everyday life, we use carbonates as an antacid to fight against the symptoms of heartburn. The chemical formula for a carbonate is CO3. All carbonates are bases and therefore have a pH value above 7. When a metal carbonate reacts with an acid, three products form: a salt, water, and carbon dioxide. The general equation looks like this: acid plus a metal carbonate, the arrow, salt plus carbon dioxide plus water. The type of salt that forms is dependent on the type of acid and metal carbonate that are used as reactants in this reaction. Let us take a closer look at a practical example of such a reaction. If calcium carbonate were to be added to diluted hydrochloric acid, the following will happen. Hydrochloric acid plus calcium carbonate would result in calcium chloride, water, and carbon dioxide. Do you think you will be able to write down the chemical equation for this reaction? If you seem to struggle, please refer to lesson 2 to sharpen up. When we write the chemical equation for this reaction, we will notice that it's not balanced. On our reactant side, we have HCl plus CaCO3. The arrow indicates the chemical reaction. The products that form are CaCl2 plus H2O plus CO2. On my left-hand side, I only have one hydrogen atom and one chloride atom. But on my right-hand side, I have two of each. In order to balance this equation, you would simply need to add a 2 in front of the hydrochloric acid on my left-hand side. Now the equation is balanced. Over to you, Ms. Lamprecht.
In this experiment, we will be examining the reaction between calcium carbonate and hydrochloric acid. We are expecting carbon dioxide to be released during this reaction, and the test for carbon dioxide is that clear lime water turns milky when carbon dioxide is produced. I have 2 test tubes for this reaction, one that will be filled with calcium carbonate and one that has already been filled with clear lime water. The calcium carbonate powder is added to test tube 1. And then the hydrochloric acid is added. Once the hydrochloric acid is added, the reaction takes place very fast. Therefore, we use this glass rod and rubber to transport the gas directly into the lime water. The hydrochloric acid is added. The forming of bubbles in this test tube indicates that gas is being transported from test tube 1 to test tube 2. Now all we have to do is wait for it to turn milky. As you can see, the lime water, which was clear at the beginning of our experiment, has now turned into a milky color, indicating that carbon dioxide was released during this reaction.
In this experiment, when the calcium carbonate reacted with a diluted hydrochloric acid, we saw bubbles starting to form. This bubbling is called effervescence. The bubbles that are formed is carbon dioxide. In grade 8, we learned how to test for the presence of carbon dioxide. Clear lime water turns milky in the presence of carbon dioxide. If we take an antacid such as ENO, it contains a carbonate which is an alkali. This counters the effects of the acid, thereby relieving the symptoms of heartburn. Let's do a recap on the reaction between acids and carbonates by doing a few questions. Can you recall which anion is found in antacids? Carbonates form part of antacids such as ENO and Gaviscon. Remember, we use antacids to relieve the pain caused by heartburn. When a carbonate reacts with an acid, can you recall which 3 products would form? The 3 products that form are a salt, water, and carbon dioxide. Now, using your working knowledge of chemical equations, please attempt to rewrite this word equation as a chemical equation. In this word equation, potassium carbonate reacts with an acid called hydrochloric acid. The products that form are called potassium chloride, water, and carbon dioxide. Most of you probably got the first compound, potassium carbonate, wrong. And don't stress, just follow with me. Potassium falls in the first group in your periodic table, and that means it only has one arm to join with an element or a compound. The carbonate anion has lost 2 electrons, and that means it has 2 arms. This means 2 potassium atoms has to bind to it in order to neutralize this ion. Now, when we look at this equation, do you think that it is balanced? No, because there are 2 potassium atoms on the left-hand side and 1 atom on the right-hand side. When we look closer, we also notice that the hydrogen atoms are also not balanced. Try and fix this by writing a balanced chemical equation. In order to balance out the potassium atoms, we will need to add a 2 in front of potassium chloride on my right-hand side. Now, when I placed this 2 in front of potassium chloride, not only did I double the amount of potassium atoms on my right-hand side, but also the number of chlorine atoms. You will also notice that water has 2 hydrogens, but my acid only has a single hydrogen atom. Therefore, if I were to place a 2 in front of hydrochloric acid, it would not only balance out the added chlorine atoms, but also the hydrogen atoms. This equation is now balanced. In the experiment between calcium carbonate and hydrochloric acid, we noticed that bubbles formed during the reaction. What do we call this phenomena? And can you remember what gas was present inside of these bubbles? The general term for bubbling in chemistry is called effervescence. Now, if you look at your chemical formula, you will see that the gas formed is obviously carbon dioxide. How would we test for the presence of carbon dioxide? If we place the unknown gas inside clear lime water, the clear lime water will turn from clear to milky or cloudy in color if the gas is carbon dioxide. Our final reaction for this term is the reaction between a metal and an acid. When a metal and acid react, the products that form are a salt and hydrogen gas. The type of salt is dependent on the type of acid and metal used as reactants. If the acid is a diluted hydrochloric acid, the salt that forms will be a metal chloride salt. In the case of sulfuric acid, the salt that forms will be a metal sulfate salt. The general reaction between acids and metals are as follows. Acid plus metal, arrow, salt plus hydrogen gas. Let us take a look at an example of such a reaction. If hydrochloric acid were to react with magnesium, the reaction will look like this. Hydrochloric acid plus magnesium, the arrow, magnesium chloride plus hydrogen gas. The chemical formula for this reaction, however, looks a little bit different. 2HCl plus Mg, the arrow, MgCl2 plus H2. Now, to indicate that hydrogen in this equation is a gas, we indicate it by putting a G between brackets after the 2. To test for the presence of hydrogen gas, we can hold a lit match at the mouth of the test tube. If hydrogen gas is present, you should hear a loud popping sound. Over to you, Ms. Lambrecht.
In this lesson, we will be examining the reaction between magnesium and hydrochloric acid. This results in the production of hydrogen gas, and we will also test for hydrogen gas. The magnesium used in this reaction is in powder form, and I will add it to this large cylinder that makes it easier to see the reaction take place. One scoop of magnesium powder is added. Once the hydrochloric acid is added, the reaction takes place quite vigorously, and therefore we add the glass disc to the top. During this reaction, a gas is produced. If this match causes for a popping sound, it means the gas present is hydrogen gas. The popping sound indicates that the gas is in fact hydrogen gas, and we created a small hydrogen bomb.
Test your knowledge by completing the following questions. If you struggle, redo this lesson and take notes. Can you recall what is the general equation for a reaction between an acid and a metal? When a metal reacts with an acid, the products that follow are a salt and hydrogen gas. Let's use our knowledge to identify which products will form in the following reaction. When magnesium reacts with sulfuric acid, two products form. If we were to displace the hydrogen atoms in sulfuric acid, I'm left with a sulfate, and therefore the salt that forms will be magnesium sulfate. And the gas that forms is called hydrogen gas. Remember that hydrogen is a diatomic molecule, and when I write the chemical equation for this, it will be written as H2. Do you think that you are well versed enough to write down the chemical equation for this reaction? Try it! Remember that the formula for sulfuric acid is H2SO4. If your chemical equation looks like this, you are spot on. But if not, please refer to lesson 2 in order to brush up on your knowledge regarding chemical equation and balancing of chemical equations. This is the end of the 6th and final lesson for term 2. I hope you learned a lot and that it was insightful.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.